Hello everyone, my name is Vaibhav Kulshrestha and today we are going to study one of the most dynamic climatic phenomena of the world and one of the most important topic for UPSC Geography GS, and it is Indian monsoon and its functioning. Indian monsoon and its functioning. But before we start this lecture, let me ask you few fascinating questions regarding this Indian monsoon. Have you ever wondered the 70% annual rainfall of India is received only in these 4 months, June, July, August and September? Why not 6 months? Why not 8 months? Why not 2 or 3 months? Why not another months except these June, July, August and September? And do you know, in earlier times, these 4 months are also known as Chaumasa in India. Earlier, people do not travel long distances because of lack of transportation infrastructure, and heavy rain could disrupt their journey, disrupt the connectivity. Okay, next, move to another question. Why Kerala received its first monsoon rainfall in the month of June, while Rajasthan has to wait for a month? The answer lies in the understanding of Indian monsoon. Basically, Indian monsoon is not merely a seasonal wind system, it is the lifeline of Indian economy. It influences the agricultural production, drinking water availability, hydroelectric power generation, and the inflation in the economy. Hence, Indian monsoon is not only important for UPSC perspective, but it is also important for understanding the relationship between Indian monsoon and Indian economy. So let's start this beautiful journey. But before we start, first of all, we will look at the roadmap of this topic so that we could know which dimensions we are going to cover in this topic. So first of all, we will know about the definition or meaning of Indian monsoon. Then we will talk about characteristics of Indian monsoon. Then we will talk about origin theories of Indian monsoon. There are two types of theories. One is classical theory, another one is latest theory, and there are four latest theories. First is air mass theory, second is ITCZ theory, the third is Monet's theory, and the fourth is jet stream theory. After covering these topics, we will move to the functioning part of the Indian monsoon. So when we talk about the functioning, it means there are various terms which are used with the Indian monsoon, like onset of monsoon, burst of monsoon, advancing of monsoon, retreat of monsoon, monsoon break or monsoon gap, and October heat and north east monsoon. Okay, so these are the dimensions of this topic which we are going to cover in this lecture. Now, first of all, what is the meaning or definition of Indian monsoon? Basically, this monsoon term, it is driven from the Arabic word mausim or Malayan term monsoon, which means season. Arabic word mausim and the Malayan word monsoon. Both means season. So this mausim, the मौसम वर्ड यहीं से लिया गया है, मौसम से बना मौसम. Season means also मौसम. So basically, the Arab traders use this term mausim and later it converted into monsoon. Why they use this term? Because Arab traders used to trade with India, and earlier the ship was driven by the wind. They used the pal. You have seen the Pirates of the Caribbean movie. So, जो यहाँ पर ये पाल है, wind pressure will move this ship. So Arab traders use this term monsoon or mausim for those winds which are blowing in the Arab Sea region. Okay, so mausim means season. It means what is the meaning of Indian monsoon? Indian monsoon means these are seasonal winds. Seasonal winds which reverse or change its direction with the change in season. How? In summertime and in winter time. In summertime, these winds are blowing from southwest to northeast. डायरेक्शन कैसे होती है? दिस इज नॉर्थ, दिस इज साउथ, दिस इज ईस्ट एंड दिस इज वेस्ट. So this is southwest, this is northeast, and the wind is blowing from southwest to northeast. On the other hand, during winter season, this Indian monsoon or these winds reverse their direction and it blows from northeast to southwest. So it is 180-degree reversal. Now, in climatology, you have studied how we name any wind. The wind which is moving from a particular direction, that direction is used for the name or naming of that wind. That direction from which this wind is moving. So it is moving from southwest. That is why it is called southwest monsoon or southwest wind. This wind is blowing from northeast. That is why it is called northeast monsoon. Or northeast winds. So what is the meaning of Indian monsoon? It is a seasonal wind which reverse or change its direction with the change in season. In summertime, it is southwest monsoon. In winter time, it reverse its direction and become northeast monsoon. Clear? Now, meaning or definition part is completed. Now we move on to the characteristics of Indian monsoon. So next heading is characteristics of Indian monsoon. These characteristics are propounded by or given by Mr. Colin Stuart Ramage. Propounded by Colin Stuart Ramage, and he provide 5 characteristics of Indian monsoon. What are these? Number 1, there is, according to Mr. Ramage, there is almost greater than and equal to 120-degree angular reversal of direction of winds with the change in season. It means when season change, the wind change its direction, and this angular reversal is almost greater than and equal to 120-degree. Next, in July month, the frequency of air increases by 40%. Third, in July month, the acceleration of wind increases by 3 centimeter per second square. And the fourth, reversal of Hadley cell. And the fifth, in comparison of last month, the rainfall increases by 5 to 7 times. Means 5 to 7 times rainfall increases in comparison to the last month or the prior month. So basically these are 5 characteristics of Indian monsoon. First, with the change of season, the reversal of direction of the wind, it is greater than and equal to 120 degree. And we have seen earlier the southwest monsoon and northeast monsoon. What is the angular difference between both of them? It is 180 degree, means greater than 120 degree. Second, in the month of July, the frequency of air increases because of the southwest monsoon by 40%. And the acceleration of wind, it also increases by 3 centimeter per second square. And the fourth is reversal of Hadley cell. Now, what is Hadley cell? Remember, in climatology, you have studied Hadley cell. So, what is the pattern of winds or air movement in Hadley cell? So, suppose this is equator 0 degree and this is 10 degree north, this is 10 degree south, it is 30 degree south, this is 60 degree south, and this is south pole, and here it is 30 degree north, 60 degree north, and this is north pole. So in Hadley cell, what happens? Northeast trade wind and southeast trade winds. These trade winds are blowing from these horse latitude, means from 30 degree north to 30 degree south latitude towards equator, and between 10 degree north and 10 degree south, these winds, these northeast and southeast trade wind, they converge together and uplift. Convection would be there because of the maximum heating effect here. Maximum insolation is received in the equatorial region. So when these trade winds converge together, they move upward, they will uplift, and they reach up to the height of tropopause. Again, in climatology, you have studied various layers of atmosphere. So the first layer is troposphere, then stratosphere, and between both of them there is a boundary that is called tropopause. So these winds reach up to the height of tropopause, and as it uplift due to temperature inversion, what happens? Not temperature inversion, but as height increases, temperature decreases. What will happen? These are cold air mass. Now it will shift toward the pole, North Pole and South Pole, but due to heavy mass, heavy air mass, it subsides over the horse latitude and it creates high pressure over 30° north and 30° south. So this cell is called Hadley cell. Then Ferrel, then polar cell. Okay, Hadley, Ferrel, polar, these are three cells. Now in the characteristic of Indian monsoon, what it is saying, when Indian monsoon means southwest monsoon is active, the Hadley cell is reversed. Normally the winds or air circulation is like this, but during southwest monsoon, these air circulation would be reversed. So this is reversal of Hadley cell. Okay, so these are the characteristics. Now move on to the origin theories of Indian monsoon. Origin theories. And first of all, we will know about classical theory. Then we will talk about latest theories. So, classical theory was propounded by Mr. Edmund Halley in 1656. It was propounded by Edmund Halley in 1656. And according to Mr. Edmund Halley, Indian monsoon is a gigantic land breeze or sea breeze operating on a large scale. So what he is saying, Edmund Halley, कि Indian monsoon, it is a gigantic. Gigantic means huge, very huge, and it is a very huge land breeze or sea breeze, which is or which are operating on a large scale. This is very basic or very simple explanation of Indian monsoon. Now, what is land breeze and what is sea breeze? How Edmund Halley is saying that land breeze or sea breeze are the real Indian monsoon? Let's understand it. In summer season and in winter season, this is land part and this is the water body, means sea. Similarly, here also, this is land and this is sea. During summer season, what happens? We means the India, it is located in the northern hemisphere, and in summer season, the apparent position of sun shift northward. So sun is here. So in summer season, this is land part, this is water body, and we have already studied in the climatology. Okay, there is a differential heating pattern in the land part and water body. The land part, it heats quickly and cools quickly. On the other hand, water body, it heats and cools very slowly. Okay. You can check it with any example, like you have visited any temple, any mosque, any architectural monuments where you have to put off your shoes or slippers, then you have to walk on barefoot. So wherever the temperature would be high, the administration of that temple or that monument, they will laid a mat and water will be spread over that mat so that your skin of the foot would not burn. Why? Because in summer season, this land part, it receive heats, and parallelly water body is also receiving heat. But because of differential heating pattern, the land part receives or absorb heats very quickly and it heats up very quickly. So what will happen? The temperature of this land part, it will increase very rapidly. So when temperature would be high, the air mass which is located just above this land mass or the surface, it will absorb temperature due to conduction method. So this land, the air mass which is located just above this land or the earth surface, it would be heated and it would convect. Due to convection, what will happen? A low pressure area will be formed over land part. So here would be low pressure. Why? Because the warm air mass is convected and uplifted upward. On the other hand, this is sea water body. It heats slowly in comparison to the earth surface or the land part, and that is why the temperature of this water body, it would be low in comparison to the earth surface. It means there would be a high pressure in comparison to this. And you have studied the wind is moving from high pressure to low pressure. So this is high pressure and this is low pressure. So wind will move from sea to land, and that is why, because it is moving from sea, that is why it is called sea breeze. And the air circulation would be like this. So in summer season, there is sea breeze. Now shift over the winter season. Now the apparent position of sun during winter season shift southward. Okay. So in winter season, again, check it with the example. In your home, in winter season, you also wear slippers or socks. Why? Because the temperature of our surface is very low. Why very low? This is water body, this is land part, and there is a differential heating pattern, differential cooling pattern between both of them. The land part, it radiate heats very rapidly. while the water body, it release heat but very slowly. That is why during winter season, the water body, the ocean or sea temperature would be greater than the earth surface or the land part. So what will happen? Above sea surface, there would be a low pressure, and above land, there would be a high pressure. So wind will move from land to sea, and it is called land breeze. Land breeze and sea breeze. So according to Mr. Edmund Halley, these are gigantic or very huge sea breeze, the southwest monsoon, which is active in the monsoon days, that is coming from Arabian Sea or Indian Ocean towards Indian Peninsula. It is moving from sea to land. That is why it is sea breeze according to Mr. Edmund Halley. While on the other hand, in winter season, northeast monsoon is active, due to which the rainfall or precipitation occurs at the Coromandel coast of Tamil Nadu. So what happens? Due to retreat of monsoon, these winds will enter into the Bay of Bengal, and due to Coriolis force, it enters into the Coromandel coast and it precipitates. So this is called northeast monsoon. But this is very simple explanation or simple classification of Indian monsoon, which do not satisfy the 5 characteristics which was given by Mr. Colin Stuart Ramage. That is why we have to move on to latest theories. Latest theories, and there are 4 latest theories. The number 1, air mass theory. Air mass theory. This theory was propounded by Mr. Fawn in 1951. It was propounded by Mr. Fawn in 1951. And according to Mr. Fawn, Indian monsoon is the equatorial westerlies which are blowing inside of ITCZ, equatorial westerlies, and ITCZ. Okay. First of all, what is ITCZ? Let us understand. ITCZ means intertropical convergence zone. This is our Earth and this is equator, 0 degree. This is 30 degree north and this is 30 degree south. And from this 30 degree north and 30 degree south, trade winds are moving from here to equator towards equator. These are called northeast trade wind. Similarly, in the southern hemisphere, these are southeast trade winds. These trade winds, they converge together. So this is equator. When they converge together, there would be a belt region where these winds will converge and uplift towards tropopause. So there will be a belt where this convergence happens. So this convergence zone is called ITCZ. ITCZ. Now, northeast trade wind, southeast trade wind, they converge together and uplift toward the tropopause, and due to this, the in the ITCZ region, the wind movement is mainly horizontal. Okay. So this region would be the region of calm. बहुत शांति होगी. But due to Earth rotation from west to east, a mild wind will blow from west to east. That mild wind which is blowing inside this ITCZ is called equatorial westerlies, because it is moving from west to east as Earth rotates from west to east. Okay, so this is westerly, and these westerlies are found in only in the equatorial region. That is why it is called equatorial westerlies. So Mr. Fawn is saying the monsoon is equatorial westerlies which is blowing inside the ITCZ. How? In summer season, this is equator, 0 degree. Okay, and this is Indian Peninsula. In summer season, the apparent position of sun shift northward. And due to this apparent position of sun, ITCZ also shift northward and located near the 25 degree north latitude. This is ITCZ. Okay. This is ITCZ. When ITCZ is located at 25 degree north, it is moving from Arab Sea to Indian mainland or the northern plain. And here in the inside of this ITCZ, there is equatorial westerly. So this equatorial westerly, it is coming from Arabian Sea. When it is coming from Arabian Sea, it will acquire the moisture which is present over the sea surface, and that moisture laden winds will be pushed by these equatorial westerlies toward Indian mainland, and due to this, what will happen? Precipitation happens. Because these winds are moving from southwest direction to northeast direction, these equatorial westerlies are called southwest monsoon. Okay? This is ITCZ. Okay. This is ITCZ, and the southern boundary of ITCZ, what is happening? This is southeast trade wind. These are southeast trade wind. And the northern boundary here, this is northeast trade wind. It means convergence will always occur in the ITCZ, and ITCZ is shifted and located at the 25° north. It means now southeast trade wind, they will cross the equator. These are southeast trade wind. These are southeast trade wind, southeast trade wind, southeast trade wind. And they will cross the equator and enter into the northern hemisphere. And when these southeast trade wind will enter into the northern hemisphere, so in northern hemisphere, the Coriolis force rotates clockwise, means it rotates toward right side. So due to this clockwise Coriolis force, these southeast trade winds become southwesterly. And the next theory after this air mass theory will say Indian monsoon is not equatorial westerly, these are southeast trade wind, because the southeast trade wind crosses the equator and becomes southern westerlies because of the effect of clockwise rotation of Coriolis force. These winds are called southwest monsoon. Okay, so that would be in the ITCZ theory. Right now, because it is air mass theory, so what is air mass theory? The equatorial westerlies which is inside the ITCZ, it is coming from southwest direction because ITCZ is located at the 25° north, and it acquire moisture which would be shifted by these winds toward Indian peninsula, which will precipitate, and its direction is from southwest, that is why it is called southwest monsoon. In winter season, what will happen? In winter season, this is 0°. Now in winter season, the apparent position of sun shift southward, and due to apparent shifting of sun, ITCZ will also shift towards southward, and now it is located in between 10° south and 20° south. 10 degrees south and 20 degrees south, and this is ITCZ. Okay, so that ITCZ, which was located at the 25-degree north in summer season, due to shifting of sun, apparent shifting of sun, ITCZ also shift towards southern hemisphere, and it is now located in between 10 degrees south and 20 degrees south. Now what will happen? The northern boundary of the ITCZ, northeast trade winds are coming. It means when these northeast trade wind, when this ITCZ were located here, northeast trade wind cannot enter in this region because this was the convergence zone. Now ITCZ is located here, so northeast trade winds becomes reactive in this region. And what will happen? These are northeast trade wind. These are northeast trade winds, and these trade winds will enter into the Bay of Bengal, and it will acquire moisture, and moisture laden winds will enter into the Coromandel coast of Tamil Nadu. So in winter season, what happens? In Tamil Nadu, Coromandel coast, it receives precipitation. And this is called northeast monsoon because it is coming from northeast direction. So it is called northeast monsoon. Okay. So this is air mass theory, which was propounded by Mr. Flown. It also do not satisfy those 5 characteristics which were given by Colin Stuart Ramage. That is why there would be some amendments in this theory of Mr. Flown. And the amendment included, the latest version of this theory is called ITCZ theory. Second is ITCZ theory. So according to this theory, this is equator, 0 degree, and in summer season, the apparent position of sun shift northward, and due to this northward position of sun, ITCZ is located at 25 degree north latitude. So this is ITCZ. Now southeast trade winds, these are southeast trade winds, because these trade winds have to reach up to this ITCZ for the convergence with northeast trade wind, so they will cross the equator, and when it will cross the equator, the Coriolis force C acts clockwise in the northern hemisphere. In southern hemisphere, this Coriolis force acts anti-clockwise. Okay, so when these southeast trade winds will cross the equator, and due to effect of this Coriolis force, they shift rightward, they turn rightward, and becomes southern westerlies, because now direction is from southwest to northeast. Southern westerlies. And these southern westerlies are called southwest monsoon. So according to this ITCZ theory, what is southwest monsoon? The southeast trade wind which enter into the northern hemisphere. And due to the effect of clockwise Coriolis force, it rotates rightward and becomes southern westerlies, and these southern westerlies are called southwest monsoon. And in the northeast, for northeast monsoon, the theory remains same. Okay, as the sun shift southward, so ITCZ also shifts southward, located between 10 degrees south and 20 degrees south. So northeast trade winds will be reactive in this region, and it will enter into the Bay of Bengal and acquire moisture, and this moisture laden wind will enter into the Coromandel coast and it precipitate. And due to, this precipitation is due to northeast winds, so this is called northeast monsoon. Okay, so ITCZ theory is the amended version of air mass theory. Now, the third theory. And the third theory is called jet stream theory. So this jet stream theory in 1960s Indian scientist P. Koteshwaram and Japanese scientist Mr. Yen, they research together and finds some interesting features of Indian monsoon. Okay, so basically this jet stream theory is propounded by Mr. P. Koteshwaram and Japanese scientist Mr. Yen. They researched together in 1960s and they find some very interesting features of Indian monsoon. Okay. This is India, and here it is Tibetan Plateau. So what they found, Mr. P. Koteshwaram and Mr. Yen, according to them, this is Tibetan Plateau. This is Tibet Plateau. the height or you can say the thickness of Tibet plateau is 6 kilometer. Its area of Tibet plateau is near about 20 lakh kilometer square. Okay, and this Tibetan plateau is made of Precambrian granite and gneiss rocks. This Tibet plateau, it is made of Precambrian granite and gneiss rocks. Its thickness or height is 6 kilometer and the area is 20 lakh kilometer square. So in summer season, when the apparent position of sun shift northward, what will happen? This Tibetan plateau, it will absorb lots of heat because it is made of rocks, and these rocks will absorb lots of temperature. So a vast heat sink zone is formed over this Tibetan plateau. Vast heat sink zone is created over Tibetan plateau. And we have already studied the ITCZ is located near or at 25 degree north. So this is ITCZ. Okay. So when Tibetan plateau will absorb lots of temperature, so the air mass located just above this Tibetan plateau, it will also heat it. The temperature will be in high, and the high temperature air mass, because of less density, it will uplift or convect and move toward the tropopause. So a low pressure area, vast low pressure is formed here, and the warm air mass is uplifted. And at the height of 12 kilometer, these warm air mass will be stored near tropopause. Due to high density of this air mass, what will happen? Near tropopause, there would be a high pressure point because now air is filled here. So high pressure center would be this. So it would be like anticyclonic condition. What is cyclone and anticyclone? Cyclone is a low pressure center. On the other hand, what is anticyclone? It is high pressure center. Okay. So near tropopause, just above the Tibetan plateau at the height of 12 kilometer, a anticyclonic condition would be formed. And from this anticyclone, what will happen? The wind streams or air streams will be ये बाहर की ओर निकलेगी, and when wind streams will be taken out from the center, then one of them this streams would be like this, and this is called tropical easterly jet stream. Okay, so in summer season, due to a vast heat sink zone is developed over Tibetan Plateau, the warm air mass is uplifted and it reached at the height of 12 kilometer near tropopause. Here the air is stored and it becomes a high pressure center. That is why anticyclonic condition is formed here, out of which the wind streams will be taken out, and one of the streams would be pass through the axis of Kolkata and Bangalore. One of the streams will be passes or crosses and parallel with the Kolkata and Bangalore axis. This stream, this jet stream is called tropical easterly jet stream. And when this tropical easterly jet stream will be found, it means it is the indicator of southwest monsoon arrival. There is a relationship, there is something relation, there is some relation between this jet stream and the southwest monsoon. What is that relation? It is not found in this jet stream theory. It was founded in the Monarchs theory, okay, जिसके बारे में अभी हम बात करेंगे. So this tropical easterly jet stream, it is the indicator of southwest monsoon arrival. Clear? So this is the jet stream theory. Now, the last and most scientific, most accepted theory, that is Monarchs theory. Monarchs theory. This Monarchs means, mon means it is taken from monsoon. X means experiment. So monsoon experiment theory, its shorter version is called Monarchs theory. Okay. In 1973, there was a joint research initiative between India and Soviet Union. At that time, Russia was Soviet Union, USSR. So in this research, many interesting facts were found which also support P. Koteshwaram jet stream theory. Okay, so what is Monarchs theory? First of all, We will draw the diagram or map. This is Australia, this is Africa. This is equator, 0 degree. Okay. And in summer season, the apparent position of sun shift northward, and due to this, ITCZ is located at 25 degree north, 25 degree north, and there are two intense low pressure area which are formed in the northern hemisphere. The first one is the Tibetan Plateau. This is Tibet Plateau, and this is a low pressure, and winds would be uplifted, and at the height of 12 kilometer there is a high pressure anticyclonic condition, out of which wind streams would be taken out, and parallel with Kolkata Bangalore axis there is a northeast, there is a tropical easterly jet stream. Okay, this is tropical easterly jet stream. We have already studied in the jet stream theory. And the second intense low pressure was formed over the Rajasthan plain, the Gangetic plain, and this intense low pressure will be extended up to the Pakistan and Afghanistan. So this is like this. This is intense low pressure. It is formed over Rajasthan plain and northern Gangetic plain and Pakistan up to the Afghanistan. When this low pressure area is formed here, the warm air mass will be uplifted, and crosses the equator, and subside over a Mascarenhas island. It is located, this is Madagascar, and Mascarenhas islands are located here in the eastern side of Madagascar. So these winds, these air will cross the equator and subside over Mascarenhas island, and when air will subside over Mascarenhas island, a high pressure area would be formed there, and this high pressure area is called Mascarenhas high pressure. Mascarenhas high pressure. Okay, and we have already studied, whenever there is a high pressure point, means there would be anticyclonic condition would be there. So when high pressure, this is high pressure, some wind streams would be taken out from here. Okay, these wind streams are, or air circulation, it is taken out from this Mascarenhas high pressure. On the other hand, this is Australia. Australia is located in the southern hemisphere. Mascarenhas is also located in the southern hemisphere. And when in India it is summer, in the southern hemisphere there would be winter. And in this portion of Australia, means the northwestern part of the Australia, there is a desert area. The greatest, largest desert is Sahara, and second largest desert is Australia ka desert. So in this in the winter season of this Australia, here is 1035 millibar high pressure. This is 1035 millibar. A high pressure area is formed above the desert of Australia, and we already know this is southern hemisphere and southeast trade winds. These are southeast trade winds. Southeast trade winds. Now, southeast trade winds, they travel all the months. In 12 months, in full year, they always travel. But this high pressure, which is formed above the Australian desert land, it will also provide a extra push, extra support to fasten, or it will increase the speed of southeast trade wind. Yes or no? This is 1035 millibar. You are running and someone is also pushing you, then your speed will be increased. Similarly, this high pressure will increase the pressure here, increase the speed of southeast trade wind, and between 44 degree east and 66 degree east, this is 44 degree east and this is 66 degree east longitude, the winds taken out from Mascarenhas high pressure and the southeast trade wind, they converge together and enter into the northern hemisphere. Means these winds will enter into the northern hemisphere. These winds, and due to clockwise Coriolis force effect, these winds shift rightward and becomes southern westerlies. It becomes southern westerlies. Okay. So these southern westerlies, अभी इसके बाद बात करते हैं. This is Madagascar, and between Africa and Madagascar, it is a channel which is called Mozambique Channel. It's warm water body. So, and this is Kenya. Kilimanjaro mountains are found near equator in the eastern part of the Africa, eastern highland Africa. So there is a difference in temperature in between the warm air mass located above the Mozambique Channel and the cold air mass located at the eastern African highland. Due to this temperature difference, a one jet stream will be originated. This jet stream is called Somalian jet stream or Findlater jet stream. So why this Findlater jet stream or Somalian jet stream is originating? Because of differential difference in temperature between the air mass located above Mozambique Channel, it would be warm, and the air mass located at the eastern African highland, it would be cold, and due to this temperature difference, one Findlater jet stream or Somalian jet stream is originated, and it move towards northern side and parallel with the coast of Africa, eastern coast of Africa, and up to the 9° north latitude. This is 9° north latitude, and here there is a cold Somalian current, and this cold Somalian current will absorb the heat, additional heat which is present in the atmosphere, and because of this absorption of heat, this Findlater jet stream will weaken and gradually disappear after this 9° north. So what is the role of this Findlater jet stream? Basically, this jet stream provides direction. Whose or whom? किसको डायरेक्शन दे रहा है? These winds which are crosses the equator between 44° and 66° east longitude and become southern westerlies, this jet stream, Findlater jet stream, will provide direction कि बेटा इंडिया इधर है, इधर जाओ. So these winds will move towards India. And in between, this is Arab Sea. When these southern westerlies will move toward Indian Peninsula, they will acquire extra moisture, and when they will enter into the Indian Peninsula, these moisture laden winds will precipitate here. That is why this southern westerly will be called southwest monsoon. Okay? When this southern westerly will move toward India or Indian Peninsula, this is called onset of monsoon. Now monsoon is coming towards India. So this is called onset. Okay? So this is the Monet's theory, in which you have also studied in the P. quotationum or Mr. Yen jet stream theory. Tropical easterly jet stream is located here, and this is the southwest monsoon. How this mechanism is happening, this Monet's theory explain the mechanism of southwest monsoon especially. Okay. So now, till now, we have completed the definition or meaning part, then the characteristic part, then the origin theories, the classical theory, and 4 latest theory. Now we will talk about the functioning of Indian monsoon. So next heading is functioning of Indian monsoon. Functioning of Indian monsoon. And first is onset of monsoon. Onset of monsoon. Onset of monsoon means the monsoon has arrived. It means arrival of southwest monsoon. This is our India. इस मैप की और भी जरूरत पड़ेगी तो इसे कॉपी कर लेते हैं. Okay. So this is Kerala, and here it is Sri Lanka. This is south west monsoon, and it has arrived at the door of India. As a guest is arrived at the door of your house, and till now he had not pressed the doorbell, so this is called onset or arrival of monsoon. And when he presses the door, means the thundering, lightning will happen. Oh, guest aa gaye. That is called burst of monsoon. So till now, this is It is now arrived at the door of India, but right now precipitation is not started. This is called onset of monsoon. Now, the second thing, second term is called burst of monsoon. Burst of monsoon means sudden heavy rain fall started with thundering and lightning. Thundering and lightning, that is called burst of monsoon. So, burst of monsoon at Malabar coast, it happens normally at 1st of June, and in Sri Lanka and Andaman and Nicobar, it happens in 25th May. This is burst of monsoon. So sudden heavy rainfall started with thundering and lightning. This is called burst of monsoon. Now the guest is pressed the doorbell and entered into your house और उठापटक हो चुकी है. Now the third, when he will be entered in your house and now he will visit your house. Wow, कितना सुंदर घर बना है. It means वो एक एक करके सारे रूम में जाएगा. This is called advancing of monsoon. Advancing of monsoon. Advancing of monsoon. How? This is southwest monsoon, and one of the branch of southwest monsoon is divided with the southern tip of India and Sri Lanka and enter into the Bay of Bengal. And this branch, which is active in the Arab Sea region, this branch is called Arabian Sea branch. And the branch which entered into the Bay of Bengal, this is called Bay of Bengal branch. So Arabian Sea branch. When this southwest monsoon or Arabian Sea branch proceed and enter into the Malabar coast of Kerala, it collide with the Western Ghat. So this is Western Ghat, and it precipitates nearly 300 centimeter or 400 centimeter at the Malabar coast and Kanara coast, and parallel with the Western Ghat, it moves northernward, and in Maharashtra near Mumbai, it precipitates 150 centimeter. This is Western Ghat, and this is Narmada Tapi Valley, and some portion of Arabian Sea branch will enter into the Narmada Tapi Valley and precipitate almost 100 centimeter here. But the eastern side of Western Ghat, it is rain shadow area, So 60 centimeter or almost 40 centimeter rainfall occurs here. And another branch of Arabian Sea of southwest monsoon, it will enter into the Kathiawar region, and here it precipitates 60 centimeter and shift and move toward the northern side, and it will enter into the Rajasthan. As it enter into the Rajasthan, here it encounter with the Mount Abu, which is the highest peak of Aravalli hills, and here it precipitate 80 centimeter. And now, because the Aravalli hills are in the parallel way of the Arabian Sea branch, that is why, and the Thar desert, this is Thar desert, the temperature is very high, and most of the area in this Kathiawar region, Mount Abu, the clouds already they had precipitated. It means now moisture compound has been decreased, so relative humidity drastically decreases. That is why in this region, in the western part of Rajasthan, almost 40 centimeter precipitation occurs, and it reaches up to the Punjab. On the other hand, this is Bay of Bengal. When this branch will enter into the Bay of Bengal, because this Bay of Bengal region is enclosed by the land from three sides, the temperature of Bay of Bengal is quietly high in comparison to Arabian Sea. That is why more moisture is acquired by this Bay of Bengal branch, and it will enter into the Malda Gap, and here in northeastern part, what will happen? This is Himalaya. The first state, that is मेघालय, हिंदी में अगर संधि विक्षेप करें, मेघधन आलय, जो मेघों का घर है, एंड वहां पर एक पॉइंट है चेरापूंजी, मौसिनराम. Maximum precipitation, maximum rainfall in the world occurs here. Almost 1200 centimeter rainfall. So this is 1200 centimeter rainfall. And in the northeastern part of India, almost 250 centimeter rainfall occurs. And now this Bay of Bengal branch will move toward the north parallel with the Himalaya. And now in West Bengal, it will precipitate near about 180 centimeter. In Bihar, 150 centimeter. In eastern UP, 120 centimeter. In western UP, 100 centimeter. In Delhi, almost 80 centimeter. And now in Punjab, both branches merged together. And because of this merger, the moisture part, which was already decreased in the Arabian Sea branch and Bay of Bengal branch individually, due to this convergence or merger, the moisture part becomes high. That is why in Punjab region or the foothills of Himalaya, almost 100 centimeter rainfall occurs. So this is the procedure of advancing of monsoon. If we talk about the dates of advancing of monsoon, it is, this is 1st of June, this is 1st of June, this is 5th June, this is 5th June, this is 10th of June, this is 15th of June, This is 1st of July, and by 15th of July, whole India is covered by this southwest monsoon. Okay, so this is the procedure of advancing of monsoon. Now we will talk about monsoon gap. Monsoon gap. The ITCZ, that ITCZ is also known as monsoon trough. Okay, so ITCZ, it is also known as monsoon trough. Basically, this ITCZ and tropical easterly jet stream, this monsoon gap is the result of the function between ITCZ and tropical easterly jet stream. How? When tropical easterly jet stream meanders like river, so due to meandering of tropical easterly jet stream, there is oscillation starts in ITCZ, and this ITCZ or monsoon trough shift northward and located above the Shivalik. Okay, and when this ITCZ shifts northward and located above the Shivalik, what will happen? In Shivalik and in northeast India, rainfall increases. Rainfall increases rapidly. Because of high rainfall in hilly area, what will happen? Flash flood, mud flow, landslide will occur in Himachal, Uttarakhand, and in the northeast of India. On the other hand, in Gangetic Plain, because ITCZ is now located in northward, it is not above the Gangetic Plain, it means the precipitation or the rainfall decreases. Rainfall in Gangetic Plain, it decreases or almost ceases, decreases drastically. In Gangetic Plain. Okay, so if this ITCZ location or monsoon location, monsoon trough location, it is for 2 to 3 weeks. If this time duration is 2 to 3 weeks, then it is called monsoon gap. And if it is for 2 to 3 days, बहुत छोटा टाइम पीरियड है, then it is called monsoon break. Okay, So difference between monsoon gap and monsoon break, now you have understood. The next thing is retreat of monsoon. Now onset, burst of monsoon, advancing of monsoon, monsoon break, monsoon gap. Now next is retreat of monsoon. Monsoon retreat. Monsoon retreat it starts from September, first half of the September. Why? Because now the apparent position of sun shift southward, and in the month of September there is autumn season in northern hemisphere. Okay, so apparent position, this is equator 0 degree, and now sun is just above this equator on the date of 23rd September. You have studied in the Earth chapter. So due to this shifting of sun from north to south, ITCZ will also shift southward. Suppose ITCZ is located here. This is ITCZ. As it moves southward, further ITCZ will further shift southward, and in winter season it will be located in between 10 degrees south and 20 degrees south. Okay. Now what will happen? The subtropical westerly jet stream, it will shift southward. Subtropical westerly jet stream it will this is subtropical westerly jet stream, short form SWJS. Okay. So in summer season, when ITCZ was shifted or located at 25 degree north, at that time this SWJS shifted northward from this Tibetan plateau, and with the shifting of south sun apparent position, ITCZ shifted. That is why this subtropical westerly jet stream it also shifted southward. And here this is hilly area, means Himalayan region. When this subtropical westerly jet stream counter with this Himalaya, it will be divided into two branches, and after this Himalaya they will merge together again. So this is subtropical westerly jet stream. This is westerly jet stream, and the southern branch of this jet stream is passes over through the above the Gangetic plain, northern plain. So when this is located here, what will happen? A high pressure area is formed over northern plain. So a high pressure is formed in northern plain, and due to this, what will happen? From 1st of September, September, बल्कि इसको 15th कर देते हैं. This is 1st of October. This is 15th of October. This is 1st of November. 1st of December. What will happen? The winds, due to high pressure, it will reverse its direction and enter into the Bay of Bengal. And due to entering into Bay of Bengal, it will again regain or acquire the moisture which is available in the Bay of Bengal region. And due to Coriolis force effect, it will shift clockwisely, means toward right side, and it will enter into the Coromandel coast of Tamil Nadu. This is Coromandel coast of Tamil Nadu, and here it precipitate. And this precipitation is called due to northeast monsoon. And northeast monsoon, इसको भी चलो साथ में पढ़ लेते हैं. North east monsoon. Northeast monsoon is active between 1st of December till 1st of March. Okay, so this is northeast monsoon. And this reversal, wind reversal, is retreat of monsoon. For example, on 26th of January, we celebrate Republic Day of India. And you have seen the Republic Day parade on TV or maybe live. You should visit Delhi near the President House on 29th January or 30th January. There is a retreating parade. Retreat means वापस जाना. On Republic Day, army आई है, parade कर रही है. On retreating day, it is now moving back to its work. तो ऐसे ही now retreat monsoon means monsoon is going away from India. So this is called retreat of monsoon. So retreat of monsoon, northeast monsoon, I have already told you with it. And the last mechanism functioning is October heat. October heat. Okay. When this retreat of monsoon starts from 1st of September, it means in the month of October, the sky becomes clearer, it becomes cloudless, due to shifting in apparent position of sun ITCZ shift southward and retreat of monsoon starts, due to which sky becomes cloudless and clear. And when it happens, maximum insolation or sun rays are received, yes or no? Because now it is clear, there is no cloud, so insolation is incoming. And in climatology, you have studied the heat budget of Earth. At that time, you have studied the incoming solar insolation. When it enter into the Earth's atmosphere, Earth's surface absorb this insolation, and after some minutes, some 19 or 23 minutes, Earth re-radiates. Earth starts re-radiation, and that re-radiation of that heat is called terrestrial radiation. Terrestrial radiation जो अर्थ से हो रहा है, that terrestrial radiation is absorbed, some of the portion of terrestrial radiation is absorbed by the greenhouse gases present in the atmosphere, and due to this absorption, the atmospheric heating starts. And in greenhouse gases, water vapors are included. Water vapors are also counted in greenhouse gases. So till now, means till September, there is lots of rainfall is already happened. It means there is abundant of moisture. So maximum insolation sun rays are received. So there will be high temperature and abundant moisture is already present. This high temperature, when these moisture, water vapor will absorb the terrestrial radiation, it would be high humidity. High humidity. So the high temperature and high humidity, ये दोनों का combination, the combination of high temperature and high humidity, it creates uncomfortable sultry weather and this is called October heat. After 15th of October, the temperature graph decreases, falls very rapidly, and just after October, temperature is in its minimum, becomes minimum, means near Diwali, आपको सर्दियाँ लगने लगती हैं, winter season आ चुका होता है. So this is the Indian monsoon and Indian monsoon functioning. In this lecture, we have studied till now what is the meaning or definition of Indian monsoon, what are the basic characteristics, how it originates, the classical way and the latest theories, air mass theory, ITCZ theory, and jet stream theory, and the Monx theory, which is the most accepted and most scientific theory till now. And then we have talked about the functioning part in this lecture. Now you can relate these functioning and the mechanism of this monsoon with Indian economy, the agriculture portion. So in GS portion, this understanding of Indian monsoon with the Indian economy, it will help to write answer in GS paper 3 and paper 1. So now this lecture is completed. Thank you.